All right, let's start. I was watching Asmongold react to this game called Reloaded. All right, all right. Let's get started. What is this? Why did I bookmark this? Oh, more Git. Let me just edit that. Well, I already got what I needed from it for VS so far. I'm not even using it, but it's in there just because, in case I want to. What am I doing? What the fuck am I clicking, bro? Jesus Christ. Okay. Function overloading. How far were we last time? Introduction. What? Oh. Did I just like barely get into it? Or yeah, it must have been somewhere like right around here. Okay. Let's get the glasses going. Hour and a half ish, and then back to see the dogs. Okay. So now we're gonna be learning. Oh, and no ChatGPT this time for the self tests. Oof. I guess unless you're paying the 300 a month or whatever, 150 maybe. It's terrible. I honestly haven't seen like a real hallucination in a long time. Every time I've used Perplexity, maybe it doesn't give the depth that I'm looking for, but it never hallucinates. It's never saying, yeah, by the way, I did not know what I was typing to you when I gave you questions in the quiz. I didn't even know what I was typing. That never happens. I never see that. But okie doke. Now we're doing function overloading, where it seems like the main premise here, or the main theme. What else are we learning in chapter 11? Overloading and templates. That could be cool. So, seems like the main point is that we could use different functions that are unique but share the same identifier but have a different interface slash signature, which is the combination of the return type, identifier, and parameters. As long as the parameters differ, it's okay. And the compiler will call the one that requires the least amount of conversion to the parameters, i.e., if we have a function that takes two floats as parameters, and I call it with 3.0, 3.2, and I call, let's just say it's sum, sure, it adds the two numbers. If I call it with 3.0, 3.2 versus calling it 3 and 2, I will get two different function results, or two different calls. If I have one that takes two floats and one that takes, actually I would have to call it with 3.2f, 3.0f, because otherwise we're truncating, narrowing conversion from a float to from a double to a float. But if I had another one that was sum or add or whatever, same name, but it took two integers and I called it with 3 and 2, then that function would be called if I put in two integers. So it just depends what I pass it for what the behavior actually ends up being. So we could have two same name functions, but totally different results. Like there could be, I'm trying to see. Trying to think of cases where we have the same identifier shared between functions, so there's function overloading happening. The identifier is used two times or multiple times within the same scope. It's just that they're unique functions because of the parameters. But where we would have totally different outcomes happening. Like, or yeah, I guess you could say that. Like, if we actually had a separate type for players versus enemies, we could pass. Well, maybe we wouldn't want to do that. Well, yeah, maybe whenever the player gets hit, we want to apply a screen shake effect. Whereas when the enemy gets hit, we don't want to do that because we're not the enemy. We don't want a screen shake effect for the enemy. I mean, sure, if the enemy was another player, then yes. But in this case, it's a single player game, so we have one that is apply damage, and we pass in a character and the amount of damage, and then it applies a screen shake to the character. but another one that we pass in an enemy and damage, and then it damages the enemy with no screen shake effect. You could say it's the same thing, and you just do apply damage and then pass in like a standard string or a name. Doesn't have to be this or this. You just have it be the shared thing. So standard, the shared type, standard string. That way, an enemy and the player of the same type. And then you just say, hey, by the way, is it the player? If the player is getting hurt here, shake the camera. That's probably a better way. But in this case, ignoring the better answer, one function would be called when we pass in an enemy, and one would be called when we pass in the character, assuming that the enemy and the character are two distinct data types, because the parameters have to differ. We can't just say, hey, standard string enemy, standard string player, because then the signature still reads, when you take out the identifier, it still just reads as apply damage, standard string, integer for damage. So they would need to be distinct. I wonder if overloading is affected by type aliasing. So if I alias standard string to be villain, but I also have another alias for it to be hero or player, and then I pass in a player to the overloading function versus I pass in a villain, I think because they're still technically the same data type, that there's no overloading here. There's no, it won't be able to, it'll just call the same function every time. There's no way to distinguish them. I can't just put in villain in one and hero in the other. I mean, I could test that. Can I even do that? I mean, I guess we'll find out. Oh, well, the easiest way would just be to make the two functions, give them the aliases, and then see if it allows you to overload them. If it doesn't, then it's saying, yo, there are two functions here, and they have, and it would actually be a redefinition in this case, if it's not able to distinguish. And I think that's probably what's going to happen. So what do we need? We need to first, we'll first include string. We need standard string. And in this case, really, excuse me, we should be passing in a string view. But I'll just do standard string to test the whole premise here. Okay, and we'll say using something is standard string. We're going to call it villain as standard string, and using hero as standard string. And now we'll say void apply damage, and we'll say villain name int damage. Oh, oops, this needs to be like that because we're using an alias, so we capitalize. And we could also say right here, void apply damage, hero name int damage. It looks like it was already maybe having an issue there. Maybe not right now, actually. Cool. Villain and int, hero and int. Seems like it's just saying villain instead of a standard string, but I bet you if I change this to be standard string and then standard string, it's gonna say the same thing. Yes, exactly. So sure, it'll replace villain and it'll be like, yo, you already have a villain int. Well, no, we don't. There's no second villain int. The problem is it's saying, yo, hero and villain are the same shit. The types here, the signatures are the same. Signatures are identical, even with type aliasing. Okay. So we cannot use type aliasing, at least like that. Sure, maybe we can do it if we have strong type def with whatever it was, something enums, pointer enums, maybe? I don't remember. Okay. Alright. Function that adds two float numbers, so we can have another. Yes, instead of having another add function, well, instead of having to have another function that takes the different parameters that is named differently, we can just keep the name the same, and just as long as the signature is different and unique, then we're good. And that could just mean that the parameters are different, and that's all. Send a message really quick. Okay. Alright. What if we also wanted a function that could add two floating points? This add is not suitable. Yeah, because if we passed in a float, we'd get a narrowing conversion because we would have a float, and an int can't represent everything in a float, much like a float can't represent everything from an int, if the int is sufficiently large or not const expression. I think the IDE is actually cool with it until it gets large. I think it does extra checking. But the compiler should technically give an error for even passing an int to a float. But maybe it's a little more complex than that. Yep, even if we were static casting the floats to beings, we would lose their decimal parts, so we would be losing value. And we would decrease accuracy. So we could have two different functions, add double and add integer, but now we have a whole bunch of different functions and we have to call them independently instead of just having one function that behaves according to what it is given. Or rather, multiple functions and the correct one. Multiple functions because the behavior needs to be different, but we don't have to manually call the specific one. We just do it, and depending on what the types are, the correct function will execute. And that would be better because each of those functions has one purpose and does one thing, instead of having one function that says, hey, are the parameters integers or are they floats? Oh, they're integers, do this. Oh, they're floats, do this. Consistent naming function. Yeah. Yeah, you have to remember them. So you're saying, hey, maybe yeah, like we have an add function. So we have add integer to literally just do regular integer addition. But then we have add component. And add component is adding a physical thing in the game world to the character. It's like attaching something to him. Or maybe like for a sword, it could be add material when you're forging a sword and you're adding something new to it, like a gem or something for aesthetic on the hilt. But instead, we could just do add, and if we're passing it a sword and a gem, it's cool. It'll do the sword add. If it's an integer and an integer, it'll just do the regular integer add. Instead of having to remember to do add sword or add this. I mean, in Unreal, it's not so hard because the functions are probably localized anyway. Like in Unreal Engine so far, I don't have anywhere that I have some big library of shit and I use that everywhere. Instead, it's kind of each thing is touching each other. There are a bunch of different classes, each with their own features, and some of the classes are members are children or parents of each other, so they can work with each other and get each other's features. But here, this is just general programming where we might have a whole bunch of different things, unrelated, still looking and calling the same functionality. So you can almost say that these are the libraries that Unreal uses in each class. So all the classes separately share the regular ass integer addition. You type in, right click, you search plus, you get add something something, and then you pass in the right shit. And then once it gets converted to code, it says, hey, there's a function for this and there's a function for this. Which one is called? Well, it depends on what the user's dragging into the adds parameters. Or in this case, the arguments. Passing is an argument. Remember the names, call the right one, and have them be different. But then we have another one that's add 2 ends, add 3 ends, add 4 ends, instead of just add. We have to change the name for each one. Instead of just saying add and passing it what it needs. Hey, I received 16 ends. Okay, well, looks like you're calling the 16 int function. I wonder how else they would be otherwise differentiated. Sharing a name in the same scope as overloaded, or called an overload. To overload add, we declare another add and give it different parameters. We have the double add and the addition add. We can call addition add 4 and 1700,000 million bajillion, and double add, and really that would overflow an end probably, but instead we could say add 47.2867432 plus 4.0. Not the case because the parameter types differ and the compiler is able to differentiate. So maybe there are different ways of differentiating. So long as it can be differentiated. If it can't, compiler error then. Overloaders. Oh, operators can also be overloaded. Interesting. I have no clue how that would work. Oh. So you have to say there's some sort of like overload declaration or something where in a given scope, if you have plus, if the binary operands of the plus operator, of operator plus, are something else, then this happens instead. So yeah, you could probably have it be subtraction. If you could say something like using x plus operator y and then like an arrow to the right and it yields x minus y, then you could overload the plus to actually be, well, no, that wouldn't work because in that case the operands would be the same, so they would have to be a different type. So it would have to be of types that the operator already doesn't work on. Because for a function, okay, you're calling a different thing with the same name. But for the operator itself, you have to give it different functionality. Because by default, it only has one type of functionality. It can add numbers, and that's it. So now you have to make it do something else. So you have to somehow define what it is supposed to do in this other case we have. Okay. We'll try to match it based on the arguments. Yes, exactly. Isn't that what we already said? It's able to differentiate them. Oh, and so this is saying, hey, this is cool because the parameters differ. Well, how does it actually happen? I mean, it would have to be because the parameters differ. Therefore, if we give them a set of arguments that fits this versus this, it chooses this or this versus this. But then what's the question of what's the question here if we say if we add what if we just do two booleans and we add them? Do they get converted to float or doubles or do they get converted to ints? I mean, I would guess int because they would undergo numeric promotion instead of numeric conversion because we'd be going between an integral type and a floating point type. I don't know if it's the least amount of conversions or I think that's what it would be. The least amount of conversion. Match it to the appropriate overload based on the arguments in the call. Overload resolution. So we call we add 1 and 2 for add. Boom. Don't know why we don't just put the inline character at the end, but okay. And then we do it again, but with 1.2 and 3.4. So in the first case it yields 3, in the second case it yields 4.6. Okay, doke. So we could have oh, I wonder. We could have two different functions and it would just be called print. Yeah, let's do that. We'll include string. Well, actually first include IOStream. Need standard character output. Include string. Need standard string. And it's simply going to be called void print what you see. One of them will be a standard string content. Oops. The next will be oh fuck, but I don't know the type for I was gonna say that one's a standard string, one is a C style string, but there's no C style string type. What other type would I want to do this with? What about Boolean versus integer? So you could say int add bool thing 1, bool thing 2, int add int thing 1, int thing 2. Okay, and we return thing 1 plus thing 2. We say standard character output bool addition Well, sure. Yeah, we could just say, yeah, sure, that'll work. Bool addition. Int addition. And then we call add one, or we say output add 1 0. Let's see which it chooses. It chose int addition by default. What if we do static cast to an int, or to a bool? Static cast to a bool. And in this case, it's a bool addition. If we instead just left it 1, in this case, it's saying there's a bool as one parameter, but there's an int as another parameter. But this is an explicit bool, and this is an explicit int. So there's an int and a bool. Well, there's nothing that takes that. Therefore, this is a bool. This is an int. So is this getting converted to an int? Or is this getting numerically converted to a bool? So in both cases, the answer... In both cases, it would require one conversion, so it can't execute. Seems like it isn't clear which one should execute. I mean, I feel like numeric promotion would probably make the most sense, but in this case, we're explicitly casting, so... Is there a way to do a literal bool? I don't even know. 1b. So we say 1.0f. One B. Yeah, I don't know what that would be. Okay. Yep, when we pass integers, it does that add. When we do floating points, it does that add. In order for it to happen, each overloaded function has to be differentiated from the others. Okay. So one is different parameters. What would be another guess for how functions can differ? I mean, it has to be different in such a way that when we call it, it's obvious. It feels like it's almost only parameters, because if I call it, maybe it's how it's used, but I don't think so. Like, for example, if we call add, and there are two adds, same parameters, one is a void return type, one is an int return type, and maybe it's even a trailing data type syntax void. Regardless, there's a void type and an int returning type. So if we use it as an initializer for a variable that's an int, well then it should be clear that we want the int returning function. Therefore, you could say that because of the call, they're differentiable from each other. But I don't think so by default, because normally, I mean, you call the only... I don't think the compiler is going to check to see how it was used in the text and then determine whether it can be overloaded or not. Because if it can't be overloaded, or if it isn't used, I think it checks it regardless. I think the compiler has to know that they're different without looking at any calls. And if that's the case, they have to be callable. They have to be. It has to be deterministic, or well, the answer, a way of finding out which is called in code, is deterministic, which has the matching parameters, or at least whose are closer. Oh, I didn't get enough sleep. Fucking Huskies, bro. I have to go to sleep early enough on the weekends. I went to bed at 1 o'clock. Or, oh god, I did. I 100% did. I forgot. Oh my god. And maybe it was 12. Even if it was 12, and I got woken up at 6, it's only 6 hours to sleep. So I'm probably short too, maybe 3 hours of sleep. Fuck. Must be differentiated. I think so far it has to be that the parameters are different, because how else do you know without looking at the code and how it's used? Oh, hey, in this case it's called by default, or it's called without using the return type. Well, maybe that's okay. We want to do that, and we want it to have a return type. We just don't use it unless we're checking if it's successful or not, because it returns the success code. If it failed, it returns 0, or if it succeeded, it returns 0. Otherwise, it returns 1. Each call must resolve. Therefore, yes. So they have to be distinct, and the calls have to be done in such a way that it yields a distinct one. So it seems like the parameters have to differ. If it is not differentiated, it will not know. Yes. If they're not differentiated, therefore they have the same signature or interface, the compiler won't know which to use. But if the call isn't deterministically able to distinguish them, or isn't able to excuse me, if the function call isn't able to discriminate between the two, and it's not, hey, this call doesn't match either one, well, then there's ambiguity in the compatible bitch. Find out how exactly they must be different from each other, and how these calls get resolved. Need to pop my knee. There we go. Reducing the number of names you must remember. Okay. Liberally. Often. Okay. Make it simpler. What's a good case? I mean, you could have two attack functions, and one of them is your player attacking, the other is the enemy attacking. You pass it either the character or the enemy, and the type of the character versus the enemy is there's a distinct. Therefore, the calls determine which is used, and the functions are differentiable because they have different parameters. And then you say, hey, when you attack the enemy, or when you are hit by the enemy, so when the enemy hits you, you get iframes after, because this is Elden Ring. Boring. When you attack the enemy does not get iframes afterwards. You can attack and attack and attack. Okay? Okay, I'm doing some push-ups real quick so I can wake up. I need some music real fast too. Just falling asleep, I can tell I'm gonna fall asleep early tonight. 100%. Oh. What are we doing? What is all this shit? Oh, this could be good. Oh yeah. Oh, that's pretty good. Alright. Let's do 30. Oh, I'm gonna sweat for sure though. Fuck. Let me wake up. Okay. 30 strict. Alright. Back to it. Let's go. Oof. Alright, I'm awake. It's a good way of getting awake. Wow. Yeah, as long as they have. Oh, well, here it is. Well, or it can be otherwise differentiated. This part I'm curious about. Oh, well. So far, it seems like I was right. So, because before, I was assuming that the types could be different. So, if enemy type, if the data type for variables that store an enemy value, is different than the data type that stores a character value, cool. But earlier when we were talking about add versus add two doubles versus add two ints, versus add three ints, add two ints and add three ints are different. Sure, the types aren't different, but the number is. So it seems like that's how they're differentiated. Maybe though, order could be. I'm not sure if the order matters. So if it's this one's a character and an int. This one's an int and a character. Well, which one is used? I don't know. Maybe it starts to get too hard to tell at that point. Because the compiler won't be able to tell which to use for show. Number of parameters is used. Type is used. As we thought, excludes these. And const. So if you did add, two different add functions, one adds a constant, one adds an int and an int, you get an error because int. Let's test it out. we'll just say int add constant int add int. Because it doesn't, it's saying what type or what full name of the parameters are, or the full name of the parameter types for the already defined one. And in this case, the int is not distinct enough. Int and constant, same shit basically is what it's saying. It's not, it doesn't care about the const part. So you can't just drop it and have another function and then pass one const values versus another. Note that the return type is not used, yes. For member functions, there are additional qualifiers too. Const something, meaning, what is a function level qualifier? I don't know what that means. We're talking about member functions. So are we saying that's the return type? I don't know. I don't know if member functions are the same in that they're just return type functions that take parameters. I don't know. And then a reference qualifier? I don't know. Oh, as an example, a const member function can be differentiated from, okay. So for classes specifically, then we can look at qualifiers. And ellipses. So we could overload based on the number. So yeah, we could say well, I guess these need to be, we'll just say A, B, C. Cool. And then if we add another, and 3 ints. Yes, the parameter number, the count of parameters, is sufficient to overload functions. As long as the numbers are different. Cool. Makes sense. Type. I gotta stop. All right. So these are different because it's int int, double double, int double double. Ooh. Really? adding int and double. Adding double and int. The order too. Interesting. Okay. The type of where they are. So it could be same shit, returns the exact same thing, and you accidentally have duplicates because you happen to be putting one first versus the other. But if you use the same results in one and another and you fucking do gravity and something, well, if you're multiplying, you might not find the same answer. So you might have to do some digging. So just don't do that. Don't have the same one and then have mixed types unless it like makes sense. Because then you have to remember why one is this and one and the other is not. Like maybe one is the number of enemies, and which is an integer, and the double is the sum of their health, but health is a double, so it's a floating point value. Whereas another is, I don't know, their an enemy's aggro value from 0 to 100 point, or well, from 0.0 to 100.0, and the int is the number of times he's been, or the seconds since last aggro time or something. Just kind of have to be careful. Yes, they're not distinct from overloads using the, hold on. Using type aliases are not distinct from the overloads using the aliased type, meaning if we say villain int and then hero int, well, if we're using hero and villain as int, or well, it should be just standard string. We'll say hero as standard string, using as standard strings. So hero and villain as standard strings. We pass in a villain and an int, or a hero and an int. Oh, sorry. The type that's being aliased over, that's being nicknamed, is the standard string. And we're not using those. So there's no distinctness between using hero and villain as using the types that hero and villain are actually describing, or just aliasing over the top of, which in this case is double. So there's no difference between those and standard string int. Therefore, won't work. Not differentiated. So yeah, we could say type def int height, and using type def int for height and age for int. And we have different prints. We print an int value. We do age value. Well, age is the same because age is an int. And height value, well, height is also an int. So none of these are differentiated from the default print because they're all still technically the same parameter. Even if the parameter names are different. Passed by value const is also not considered. Therefore, it's not going to make a decision depending on whether, or based on whether it receives something that's const or not. Which seems like it makes sense, because maybe we want to pass a function something to get information about somewhere that currently exists in memory, and we pass it a current reference. But maybe another time we pass it a constant reference to get the same shit. Oh my god, now I need a whole nother thing just to do one for the const reference because they're distinct from each other. So, I mean, I could handle it in the same one, but I could also do it the other way. So, I guess if we didn't overload it, then it would still be okay. Like, I mean, if we did the static cast from a floating point to an int and then passed it into add, we don't need two functions. We just have to cast the shit beforehand. But it's not as accurate. Okay. Let's see if I got bit or if it's like an arm pimple or something. Ellipsis? I've never even seen this syntax before. A unique type of parameter differentiated from int. Let's call the foo for 5. We'll match that and not that. I don't know what call you would do to access the second foo. I have no clue. The return type is not considered. Okay, so this is all rehashing the shit from the beginning, but it makes sense. Return type is not considered. Makes sense. Yeah, so if we're saying, hey, get random value, int versus double, yo, if we call it, the compiler has no clue. It's ambiguous. There's nothing in the call, besides maybe if you're assigning the value to something, that tells the compiler which function should be called. One returns an int, one returns a double. Overloaded differs only by return type. Yes. Yeah, and you saw that. You don't know which one. Yeah, which means you don't have to evaluate the entire expression. Makes sense. Yeah, because you don't have to read the rest. All you have to do, look at the call, and what's in the call. Done. That's it. You don't have to be like, you don't have to figure out, oh, it's being assigned to an int, therefore use the int one. Oh, it's being assigned to a float. Well, maybe I want the narrowing conversion. So it wouldn't be helpful. Then you wouldn't be able to do it because it would be too safe. Like if I just wanted to drop the trailing 0 shit, or drop 0.3 alpha 5 and just get 5, well, it wouldn't allow me to call it like that, because it would say, hey, this is being assigned to an integer, there's this issue. I mean, it's already going to do that if there's a narrowing conversion. Yes, we can always determine it based on the arguments. Cool. If return values were used, we wouldn't have a way to tell. I mean, if it was also used... Or yeah, if we called add and we passed in 3 ints, and then another time we pass in 3 ints, and the only difference is the return type, then how would it know whether it's whether to use the int one or the int returning one or the void returning one? The void returning one simply prints the sum. The int one returns the sum. Which one do we use? They differ only by return type. Excuse me. Well, if we're calling the void one alone, might be the void. If we're calling the other one alone, well, if we're calling the function alone, it might choose the void one. If we're calling it to assign the value to something, not void, then it might call the int one. Which means we have to figure out more than just the function call itself. So for simplicity, it makes sense that we would limit this to just being the function call. So otherwise we have to read it, see what's happening. And maybe with function pointers and other things that gets complex and we have to read deeper into things just to figure out what one call is doing. So in this case, if they truly are like that, if the parameters are not differentiable, they're not different, then, well, just change the name. You have to say whose door you're knocking on. If both doors are red, you gotta say something else. Yo, alright, we can't use the color anymore because they're both the same. His door is taller, we do the door height. So we say, open 6-foot door versus open 8-foot door. Boom. The signature, the type signature, is the parts that are used for differentiation. Well, in this case, so it's not the identifier, or not the return type. It is simply the parameters and the identifier, not the return type. The name. Oh, true. There's also the number. And then function level qualifiers. Well, the qualifiers are not here, but for member functions, seems like yes. Yeah, so we do use the name because it's only overlap if the names are the same, the identifier. It's only overlap if the identifiers are of the same type in and order and number. Not include the return type. Name mangling. Jesus. The compile name is mangled, so the linker has unique names. Okay, so the linker doesn't like the overlap, but the compiler is cool with it. And it does the translation for the linker. It's just like saying, hey, I watched Queso play this game where you're packaging. You're in some not haunted, but this monster infest. Well, I think it's one monster, but there's one monster in a warehouse. It's called like Warehouse 6 or 33 or something like that. Not 33, but maybe 3, Warehouse 3, I don't know. Something like that. Where every night you go into the warehouse and you're shipping packages and shit. Well, it's like saying that if I'm working in there and the guy who takes the packages from me can differentiate between them just based on the weight, well, people later on don't necessarily know what's in them, so he actually has to do the writing and say, hey, this one's heavy, I know what's in here, he's got metal. Oh, this one's light, I know what's in here, he's got foam. The people later on don't necessarily know which one's metal and foam. They should know. The linker maybe should know, but the compiler, the guy who's taking the package from me, does his own hard work to say, hey, this and this, these are distinct. That way the guy who takes it from him, who doesn't have any arms so he can't tell which one's heavier, sees and just has to press buttons to do shit based on what they look like instead of what they feel like, because they evaluate them differently. The compiler can evaluate them based on the arguments and other shit, whereas the linker only has access to the names, seems like. Might be mangled to underscore function underscore v, whereas this could be underscore function underscore I. So on the source code, they're simply overloading function. In the compiler code, they are distinct for the linker, thus mangling. No standardization. So compilers produce different results. Interesting. Okay. Overload resolution and ambiguous matches. Let me wash my hand real quick because I was scratching my freaking little whitehead action. Shouldn't have. Okay. Which attributes are used to differentiate? Yes, we have the number of parameters, the types of parameters, meaning each individual parameter, because int float is different than float int, and the identifier. Number of parameters, types of parameters, identifier. Name. Compiler error because of ambiguous. Because of ambiguity. any call is made, there must also be a function declaration. Meaning that what, you would need a declaration for both of them, is what we're talking about? Is it the same process where they're unique based on the same factors, characteristics? There's only one function that can potentially match a call. Yep. Either matches or doesn't. And if it matches, maybe some conversions happen to make it match, like passing standard string to a string view or something like that. Which one? Ah, true. Which one is the actual match? So yeah, the functions are differentiable. And we call based on these arguments. Which one is best? Especially if conversions can be made. Like calling int addition. Ints can surely be converted into floats for floating point addition. What's the process? Matching a call to the overloaded function. So we're saying, hey, you called here. Does it go this one, or this one? Which one? And there are factors that it's evaluated upon. Yeah, it's either an int or a double, boom or boom. Well, what happens if it doesn't? Yeah, this is where we get into what, conversion ranking or something, where either the different kind of conversions are tallied up so that this one takes priority over this one, or it is simply by the count. This one has one conversion, this one has one. But then they must differ in that number, probably. I think that happened earlier. They convert similarly or something like that, it said. For example, print A, and A is a character, so it could be numerically promoted to an int, or it could be numerically converted to a double. And then a long could be numerically converted down to an int, or numerically converted over to a double. Just because there isn't an exact match doesn't mean that there can't be one. So they could be found. How it matches specific call to the overloaded function. Okay. Resolving them. Sequence of rules to determine which is the best match. Okie doke. Okay. Ow! Oh, the delay after you pinch a freaking piece of skin. Oh, the pain kicks in so late. still doesn't necessarily, yeah, exactly, here it comes. I was going to say, it doesn't necessarily say how the matching process works. What happens? Character can be converted to this. Along can be converted to that. Which one is chosen? First, an exact match. Is there one where they match? I.e., we're calling add int. Hey, is there add int? Ooh, there's only add float and add long. Damn. Or in this case, yes, exact match, int, or 3.4, oh, exact match, double, double. Therefore, exact match between the first call and the first function, and the second call and the second function. Trivial conversions to see what's happening. Oh, here we fucking go. L value to R value. That's new. I think. Yeah, that's later. 12. Oh, const int versus const double reference. So it converts the int to a constant, which is maybe easy. Well, that's easier because we're just qualifying it, not actually even converting the full type, I don't think. And then the call's good, resolved. For 2.3, we're saying, oh hey, well, two things. I could say, alright, we have to numerically convert 2.3 to an int, so from a double to an int, or from a double to a double reference. Or a const double reference, rather. So a non-reference to a reference, and a non-const to a const. Or in one time convert it to a const double, okay. References. The trivial conversions. So the trivial conversions first are, it's basically saying, hey, there's an argument here and it has ints. It doesn't explicitly, or it doesn't exactly match the parameters. Okay. Well, the parameters are constants. So, or well, I guess it'll say, hey, int float, no match. Okay, let's do the trivials. Let's try making them const or non-const, or a reference or a non-reference, or something else or not something else. Ooh, still no match between int and float. Step 2, here it comes. So it seems like promotion does take priority. Matches via the trivial are still considered exact matches. So this is ambiguous, where we have an int and we have an int reference. Well, it's a trivial conversion to go from int to a constant reference. So adding const and making it a reference, same as if it didn't do anything at all. Therefore, it's just as trivial as leaving it alone. Therefore, this is ambiguous. Numeric promotion. Yes. Yep, so if we had A, which is a character, it'll get promoted to an int. If we had true, which is a bool, could promote it to an int. We have 4.5f, which is a float, promoted to a double. Cool, these are all promotions. Because ints are the natural type for this architecture, same as doubles. And the things below them are of more narrow type. Cool. Oh, okay. Had to recharge for a sec. Yep, so in this case, we're saying, oh, promote. All right, there's a match, and it's a single match. All right, promote, single match. Oh, promote, single match. Cool, we're good to go. Exact match for character couldn't be found. Promotes to an int. Cool, so it resolves to int. If not numeric promotion, I figure, yep, conversion. So in this case, we pass a character. Ooh, and a character cannot be. Oh, so in this case, eventually it chooses the first foo double. And the reason is because conversion comes before standard string, whatever step 4 is, if there even is a step 4. Or step 4 could be the compilation error, maybe. I don't know. But we say, hey, A is a character. A character is effectively a 1-byte integer. Ooh, an integer to a floating point, or a floating point to an integer. These are not numeric promotions. These are numeric conversions. Well, there's no exact match. There's no foo character. There's no foo integer. So there's no numeric promotion either. Therefore, that's the only value that it would be promoted to. Therefore, numeric conversion, what we got? We got a short, we got a fucking long, we got a long, we got a float, we got a double. Oh, we got a double. We got a double, we got a double. All right. Well, the other one isn't converted by then, so it's only one. There's only one match. Yep. Yes, so promotions happen before conversions. Makes sense. If no match is found via numeric conversion, any user-defined conversions. I don't even know how to do that. But if we could, some types, classes, can define conversions to other types that can be implicitly invoked. Meaning, I could have a class that somehow says that a standard string converts to a float somehow. And if that exists, and I guess it's in scope in this case, then it will try and convert like that. Maybe? Alright, let's see. So, haven't covered classes yet. There's a new class type called X. There's a conversion from X to an integer. Operator. Oh. Operator to an integer. No parameters. So does that just mean you call it I don't know what the fuck I'm looking at. Because it looks like operator is the return type and int is the identifier here. Does that mean you just call it with the parentheses? From X to int. There's foo for an int, and there's also for a double. Well, if we say X is the type, there's the class, and X is the object, so we're creating object X of type big X. And then we say foo X. Well, X isn't an int nor a double. It cannot be numerically promoted to either, nor can it be numerically converted straight away. Is there a user-defined conversion? Oh, within the class X, there is. There is a conversion from X to an integer. X to an integer. Excuse me. Well, if it's to an it, I have no idea. So we'll check to see, hey, is there a foo X? Oh. So the point here is that X is converted to an int so that foo int executes. No? User-defined conversions from X to int. It will convert X to an int and match with foo int. It may do other stuff too. So if we say, hey, it says foo int, but we only have foo long. We started with a damn object of a class, like an instance, and it converted into an int. But the only function we have is foo long. So then it converted it, and then it implicitly numerically converted it to a long. It's not a promotion even though it's wider, because it isn't the standard type. Yeah, so if the user-defined one was to a character, it would still work in this case because it could then promote to an int. Yes. User-defined conversions for class types by overloading the typecast operators. What the fuck? Huh. I don't know how that works. Seems like maybe you can create an object using a number and then it creates it and then assigns it or something. Step 5. If no match is found. Cool. That's it. That's it for the new learning. I am fucking spent. Okay.